What does it really mean for an AI to think? Today, we're diving deep into Interview Angular. Change detection performance. Change detection is where Angular performance moves from folklore to engineering. Every click, timer, or HTTP response can trigger rendering work. Modern users judge that work very harshly. Core Web Vitals sets 200 milliseconds as the limit for good responsiveness. Interview answers must explain how Angular updates, more specifically, how to prevent unnecessary updates before they steal the frame. Notably, this requires understanding the change detection strategy. Thus, the goal is to optimize performance at the core of the framework. But here's where it gets interesting. The bottleneck is not Angular. Most slow Angular screens are not slow because the framework failed. Next, they are slow because rendering has no boundary. Importantly, the default strategy is safe because it checks broadly after asynchronous activity. Thus, safety becomes expensive when large component trees respond to the same trigger. More specifically, repeated lists and impure pipes add to the cost. Notably, leaking subscriptions and heavy templates also contribute. The bottleneck is invisible until a simple interaction starts dragging the whole application behind it. So, what's the real problem? Let's talk about rendering is a scheduling problem. Rendering is a scheduling problem, not a mysterious background force. Next, Zona.js observes asynchronous browser activity and informs Angular. Importantly, Angular's change detection is highly optimized. Thus, it can still slow applications when it runs too often. More specifically, strong candidates control the blast radius. Notably, they do not blame the cycle itself. This raises a critical question. OnPush creates rendering boundaries. OnPush is the boundary that turns rendering from automatic suspicion into explicit evidence. Next, a component subtree is checked when inputs change or events happen inside it. Importantly, observable bindings emit through the template or the view is manually marked. Thus, this forces architecture discipline with immutable inputs and async pipe. More specifically, signal-driven state and predictable data flow are required. Notably, the result is fewer places Angular must inspect under pressure. Angular handles rendering more efficiently with these boundaries in place. Now let's zoom in on manual control is a scalpel. ChangeDetectorRef is the manual override and interviewers. Listen carefully here. Mark for check, schedules an on-push view to be checked later. This preserves Angular's normal rhythm and avoids unnecessary checks. Detect changes checks immediately and is useful for isolated local work, but it can be dangerous if abused and disrupts the cycle. Detach can remove a view from the global cycle and reattach restores it. Precision beats panic and gives control back to the developer. Angular provides these tools for fine-grained management. Here's something most people overlook. Zoneless makes reactivity explicit. Zones are no longer the only story. Angular provides zoneless change detection. The official API states provides zoneless change detection configures apps not to use Zone.js. This changes the contract. Updates must come from explicit notification sources, such as events, signals, async, pipe inputs, or manual. Marking the future-facing answer is not remove Zone.js. It is make reactivity explicit. Angular. Think about this for a second. Identity beats repainting. Lists are where hidden rendering debt becomes visible. Without a stable identity, repeated DOM can be torn down and rebuilt. Track by or modern at for tracking gives Angular a key to preserve elements. This allows Angular to execute the minimum necessary DOM operations. Virtual scrolling extends the same philosophy. Do not render what is unseen. Angular 1 continues to improve with these techniques, and this is where things get complex. Ship less before you optimize more. Initial load performance is the second battlefield. Lazy roots keep features out of the first payload. Deferrable views with @deferred delay non-critical dependencies. Importantly, this can reduce initial bundle size. Angular documents that this improves core web vitals. More specifically, LCP and TTFB see improvements. Preloading then fills the gap after the critical path, Angular 2, Angular 2. But here's where it gets interesting. The build pipeline has opinions. Bundle optimization is the build time version of change detection discipline. Tree shaking removes unused code when modules are structured for static analysis. Code splitting keeps rare journeys away from common journeys. Pure pipes and memoized selectors prevent expensive recalculation from becoming template noise. Signal computed values also help avoid unnecessary recalculations. Memory leaks matter because abandoned subscriptions keep old views alive. Notably, these techniques improve performance and maintainability. So, what's the real problem? Let's talk about the senior answer is a workflow. The winning answer becomes an operating model. Next, measure interaction delay and isolate the hot path. Importantly, reduce the check tree with OnPush, thus stabilize identity with tracking. More specifically, defer non-critical UI. Notably, virtualize large surfaces, clean subscriptions, and inspect bundles. This topic proves you can design Angular applications instead of hoping the framework will rescue architecture.